All right, let's start. Good morning, good afternoon, good evening to everyone following this event online or the recording afterwards. Today, we will be talking about a topic that I love, which is all the performance features available in modern versions of SQL servers as well as in Azure SQL. Thank you for the organizing team to invite me to present today. So in the next hour, we will try to understand a little bit all these features that we can take advantage of in order to have a good performance and a stable performance within our SQL Server environment. So let's start. My name is Javier Villegas. I am IT Director in the DBA and BI services at Mediterranean Shipping Company. I've been working with SQL Server for over 20 years. I am Microsoft MVP in the data platform category, as well as a Microsoft certified trainer. Recently, I joined the board of advisors for the Azure Data Tech Communities, an initiative from the all data communities, which is empowered by Microsoft. And also consider myself or define myself as a technical speaker, being part of a bunch of events over the last several years. I'm also a member of the SQL Argentina meetup group. I am from Buenos Aires, Argentina. We run our meetups regularly in Spanish down here. So you are all welcome to participate if you would like to. In the left side of the screen, you see my contact information, my email address, Twitter, LinkedIn, and even my blog. So if you want to contact me to do a follow-up of any of the topics presented during this session, feel free to reach me in one of these ways. Or if you only just want to network and stay connected, I'm welcome to be there. So let's start. Let's define first what Azure SQL is, right? This is the new umbrella that Microsoft has put on as the new, let's say, SQL Server foundation, which actually includes multiple products and services. One of them is SQL Server running on virtual machines, right? Then Azure SQL database, and also managed instance. You will also see in this marketing slide the introduction of SQL Server Edge, right, which is the possibility of running SQL Server on an ARM device, like, for example, Raspberry Pi for certain scenarios at the edge, right? So this is the foundation of Azure SQL. Additionally to this, we also been working with SQL Server for many years, right? Particularly, I had started with SQL Server 6.0, and now recently working with SQL Server 2019. Each of the SQL Server major versions that we saw over the last years have introduced certain features in different areas: BI, performance, security, etc. Today, we will focus on the ones that Microsoft consider as the modern version of SQL servers. Those are SQL Server 2016, 17, and 19, right? So all the features and the points that we will discuss today are mostly based on these 3 versions, as well as managed instance and Azure SQL database. So going back a little bit to the definition of Azure SQL. We said that Azure SQL is a set of products and services. If we do another categorization, we can also define as infrastructure as a service and platform as a service. In the bucket that is infrastructure as a service, meaning that you have to handle the whole infrastructure around SQL Server. You have to provision a virtual machine with an operating system, take care of applying the patch, set up the clustering if you have to do high availability disaster recovery, apply the patch, takes the backups, etc. This is the option. SQL Server running on virtual machines, which is a great approach that Microsoft is giving us, because through the Azure portal, we can easily select which SQL Server version and edition we would like to use, right? And also configure the overall infrastructure, like the disk, the memory, number of virtual cores, etc. And in a matter of few minutes, we are up and running on these virtual machines. On the other bucket, which is called platform as a service, we have two options. One is managed instance, and the other one is Azure SQL database. Those are, as Microsoft like to say, just SQL, right? But since we said that it's part of platform as a service, we only have access to a SQL Server endpoint. What does it mean? Microsoft takes care of the infrastructure that is running behind the scenes on these two services. So we don't have to take care of applying the patches. We don't have to take care of setting up availability group, because everything is part of the service, right? Managed instance is almost 100% compatible with SQL Server on-prem, right? With the latest version that we know, right? And Azure SQL database is mostly targeted to modern applications, so it has certain characteristics that make it unique and specific for modern applications. This introduction is basically to put everybody in context on what we're going to be talking next, which is how we can achieve good performance using the new features on all these platforms, right? So as we said, today SQL Server is running almost everywhere. Right. I remember all days in where I was only running SQL Server on Windows platform, and now we can run it almost everywhere. So as we said, SQL Server running on virtual machines or bare metal servers. Since SQL Server 2017, we have the possibility of running SQL Server on the major Linux distributions like Red Hat, Ubuntu, and SUSE. Then we have the possibility of running SQL Server in containers, and also if we need to orchestrate a set of containers, we can also run it on Kubernetes. In the Azure platform, as we said, we have virtual machines, we have managed instance, Azure SQL database, and as I mentioned, SQL Server Edge for IoT scenarios, right? So mostly everywhere. Quite different to what I used to see several years ago, right? So just to conclude this introduction of what Azure Server is, right? We're going to do a specific set of description on these things that Azure SQL gives to us, right? First of all, we have the possibility of having business continuity and high availability. That means we don't need to worry about a bunch of things that we have to take care of in our data centers, right? Microsoft is providing us with a foundation of multiple things that will allow us to achieve high availability and disaster recovery quite easily. In terms of handling backups and do the what they call long-term backup retention, as well as having the possibility of distributing the backups on different regions to achieve, let's say, certain objective that we need to do certification, for example, right? You know that if you need to pass a DR scenario, you have to store your backups in outside your main data center, right? With this services, we have the possibility of giving all this responsibility to Microsoft. They're going to be taking care of doing the backups, maintain the backups, and also, right, do the sheer replication of the backups. So we have it distributed in multiple locations. Another important thing that I love from the Azure SQL is basically the way to scale, right? We can easily, from the Azure portal, right, change the amount of virtual cores, amount of memory, improve the I/O, adding better disk with faster, specs, etc., with few clicks. If you consider to do this on an on-premise environment, well, remember that you have to buy the hardware, find out the spot to do the maintenance, etc., and that could take at least few weeks, right? In Azure is like this. You do it right away, right? And then all the advanced options in terms of security, monitoring, and built-in intelligence. That's the parts that we're going to be talking about, the built-in intelligence. As we mentioned, Microsoft always say that Azure SQL is just SQL. So if we need to do a proper monitoring, a proper, troubleshooting in any of these options that we just finished mentioning, right? We need to take care of the thing that we've been talking for the last 20 plus years: memory, CPU, and I/O, right? Those are the three main pillars in where we have to worry about and do the babysitting, if you would like to say. And and in order to be able to have a stable SQL Server environment, right? What we've been also doing for the last many years is taking care of the maintenance plans. We mentioned the backups, but we also have to maintain the indexes with reorgs and rebuilds. We need to take care of updating the statistics. Multiple things that we've been doing all the years. All those things remain today for the SQL Server on-premise, as well as all the other options that we mentioned. If we start digging into the monitoring and the performance troubleshooting specification, right? Again, consider this is for all the component of the Azure SQL family that we mentioned. We have this thing that we've been working for many years. One of them is query store, in where we're going to discuss it in deep in few minutes. Also, we have dynamic management views, something that we have available since SQL Server 2000. These are read-only objects, system objects that SQL Server provide to us in order to understand what is happening behind the scenes, right? For example, all the processes that are running, the status of the indexes, status of the availability groups, how we are using the indexes, if we have logs, etc., etc., etc. There are certain group of dynamic management views and functions that are exclusively for managed instance and Azure SQL database. Again, consider that we don't handle the infrastructure behind the scenes. So in certain areas we need to have things exclusively for these two options, right? But again, the majority of these DMBs, DMFs are exactly the same in all the options we have available. So when we talk specifically about performance, right, we're going to be focusing on these ones that are, again, starting in the modern version of SQL Server. Query store, as we mentioned, introduced in SQL Server 2016. Automatic query tuning in 2017 that runs at the top of query store. We're going to be covering in deep each of these options. Adaptive query processing in SQL Server 2017 that then in 2019 it was rebranded with additional functionality, call it intelligent query processing, IQP, right? All the column store and in-memory OLTP options that we have within SQL Server and in SQL Server 2019, all the changes related to Tempdb metadata that allow us to have better performance on certain scenarios related to Tempdb object. So the way that we work in this new intelligent database way, right, is basically that Microsoft has certain components that are constantly monitoring the activity within the user database or eventually within the instance, right? And giving us recommendations in order for us as DBA or developers to make changes, or in other cases, just adjusting the behavior to accomplish a more stable and better performance, right? And with that, we're going to introduce to Query Store, right? Query Store is what I like to say, the flight recorder of SQL Server, right? With Query Store, we have the ability of enabling Query Store at user database level, and this will capture all the activity, all the usage within the user database. What do I mean with that? Every single store procedure, every single process that runs in that user database will generate an execution plan and will be stored in the plan cache, right? And Query Store will save a copy, right? After the plan gets created, and then when that query get executed, it's gonna come up with certain statistics, right? Like how many times it was executed, amount of reads, writes, usage in Tempdb, etc., etc. All that information related to plans and runtime statistics get stored into Query Store, right? So we will have the possibility with within Management Studio to see how the different queries behaves over time. And eventually, right, if we consider that we need to introduce any change, we can do it directly from Query Store. What do I mean with that? We all know the plan regression situation, right? Where, you know, a process get compiled and SQL Server will try to get the best execution plan as quickly as possible, right? Sometimes that plan change because of multiple factors. One of them is statistics, for example, right? And the new plan could be not the best or not as good as the previous one. So the new resource usage, like, for example, CPU consumption or duration is worse than the previous one. So if we detect those cases, right, we can manually force a specific query to use right? A previous plan which is stored within Query Store. We will see it in action in a minute. How does Query Store work? Well, as we mentioned, SQL Server compiles the store procedure, right? And then store the plan in Query Store. Then it gets executed and sent all the runtime statistics into the Query Store schema. This is information that gets stored within the user database, right? Something to consider here is that Microsoft has Query Store available in all the Azure SQL components, right? But in SQL Server as a product, right? Query Store is disabled by default. In Azure SQL components like Managed Instance or Azure SQL Database, every time you create a brand new user database, Query Store is enabled by default, right? So in on-prem, you have to enable it manually if you would like to do it in one or multiple user databases. In Managed Instance or Azure SQL Database, it is enabled by default. It's quite simple to enable it. You will go to the database properties. You will have an option, Query Store, and just enabling it by default will give you the possibility of start using it, right? Then there are certain recommendations or best practices on how to use Query Store for certain scenarios, like, for example, heavily load transactional environment, right? So here we have a recap of what we can do with Query Store, right? And then how do we consume the information stored within Query Store, right? From Management Studio, we will have an option called Query Store, in where we have a set of predefined reports in where we can see all the activity for, the different workloads running within our user database, and understand and see those values that were stored, the plans that were changing over time, as well as the runtime statistics, right? And eventually, as we said, right, we can force from Query Store dashboard or using T-SQL, right, for a particular query ID to use a plan which was previously generated. Here there are some best practices on how to use Query Store. One of the things that I like to highlight here is that you can use it when you are migrating from one SQL Server version to another, right? And compare if the majority of the plans generated have performance improvement, or if there are certain regressions, and this will help you a lot to identify those cases. There is also a link down there that is pointing to best practices on how to use Query Store in certain scenarios, right? Again, this is really powerful, introducing SQL Server 2016. So it will allow you to capture all this information, and then you as a DBA can manually force to use a previous plan. That's great, but let's assume this scenario. We have a process that runs every night, and one particular day we start seeing a regression, right, at 3 a.m. in the morning, right? So at 3 a.m. the plan changed, and now instead of running in a few minutes, now it's taking several hours. So how do we handle this? I mean, someone has to be in front of the Query Store console in order to identify the process and manually set the execution plan to use the previous one and go back to the few minutes execution time. Again, someone has to be in front of the console at 3 a.m. In SQL Server 2017, Microsoft added an additional layer to Query Store, which is called automatic query tuning, right? And what it does basically is that if SQL detects that there is a regression on a particular query because of a plan change, automatically and immediately will set the previous last known good execution plan without us having to do anything, just of course enabling the feature, right? This is really awesome because again, if we see this problem at 2-3 a.m. in the morning, we don't have to be there in order to get the plan fixed and the let's say the report or whatever it is running in a stable performance as it used to be, right? So again, this is automatic query tuning. We will see it in action. How does it work? It is constantly checking the information within Query Store. It is adapting the behavior, just automatically setting, the previous last known good plan and verifying constantly. Though this is a constant process that, even if it is fixed automatically, it will keep monitoring to see if eventually it has to do a follow-up or a further adjustment, right? So this is mainly focused for the problem in where we encounter plan regressions because of the situation that which is, for example, change of indexes. So we keep running on a certain duration and suddenly, boom, it goes to the roof because of the current plan is not good as before, right? So now automatically we have the possibility of fixing this. You have to consider that all this get vanished if you restart SQL Server, right? This is important. It's not like it's going to be there forever, right? This is a constant process that learns, adapt, and adjust. Very good. Switching to another topic, adaptive query processing. This was first introduced in SQL Server 2017, right? And this is actually awesome. If you remember historically within SQL Server, when the plan of a particular procedure get created and stored in the plan, it is, let's say, statics. It cannot be changed, right? Unless you delete it and it try to come up with another plan. But, consider this situation. If you have a store procedure that you executed for the very first time, and if we talk about memory grant, right? So the very first time that it runs, SQL Server say, hey, I will grant you 10 megabytes for this execution. Very good. So the following execution will use that plan that is in cache and has granted 10 megabytes. Let's say that for any reason, let's say parameter sensitive plans, instead of using 10 megabytes, right, and it was granted on the very first execution, it is using only 1 megabyte, right? So you say, it's not a problem. I'm only using 1 megabyte of the 10 megabyte that I have granted. It's not going to be a problem. I won't have any performance problems. That's right. But consider that store procedure is being executed hundreds of times per minute, right? So it will be for each of the execution that we have in parallel, right? It will be getting 10 megabytes of memory and only using 1. So it's going to be wasting a lot of memory. And that will generate a problem because you are taking out memory for other processes, right, that you are not using, right? So this was a problem. And then consider the other possibility. If the plan has 10 megabyte granted, but for any reason it is using 20, right? It's going to be using the Tempdb to spill data over there in order to get your procedure executed, right? So that plan that was initially granted with 10 megabyte, it will be using it no matter what. Okay, with adaptive query processing, Microsoft sorry about that. With adaptive query processing, what Microsoft is doing is just, okay, when we get the plan generated, let's provide feedback about the plan to see how well or bad is used, and then do certain adjustment to the plan in order to adjust, for example, the memory grants, right? So that is one particular scenario, memory grants. Then there are other scenarios like, for example, the ones that were introduced back in SQL Server 2017, which are, well, as I said, memory grant feedback, batch mode, adaptive choice, and interleave execution. Adaptive choice is another one that I like a lot because, again, considering the same premise, right? The plan get generated and used, over time. But for example, for the joins, the first time that you are doing a join, the tables that are coming through the join may have certain amount of rows returning, and SQL Server will decide to use a specific type of join. But then let's say that tables get populated and we have many more rows returning on that join, right? Well, maybe in that point, it will be better to use another type of join. But, you don't have this in the plan that is in cache, right? Well, with these adaptive joins, you will see that we have an additional or a new operator that will decide between two type of joins depending of the amount of rows coming from each of the tables that are involved with the join. So again, adapting the plan based on the feedback. In SQL Server 2019, Microsoft added an additional layer to this initial approach, and it renamed the whole framework as intelligent query processing, right? If you see on the slide here, the ones are the rectangles that are in bold are the new ones involved in 2019, and the ones that are in regular fonts are the ones coming from SQL Server 2017, right? And it added additional functionality to this, feedback from the plan. One of them, which is quite interesting, is the possibility of having scalar UDF inlining. What is that? Well, you all know that SQL Server is historically was not doing so well when you have a scalar function involved in your query, right? The engine was also assuming that the scalar function has almost no weight, right? And was giving it, just considering, oh, this is super light, so let's not consider it within the overall plan. Well, we all have seen over the years that developers sometimes get quite creative and put a bunch of business logic within a scalar function, right? So in certain cases, that weight that was assumed like very light, right? It was not that case. And we were having, as DBA, we were having to deal with that, with problems on CPU consumption, et cetera, et cetera. Now, within intelligent query processing, Microsoft is coming up with the plan that is stored within the Scalar UDF function, and then embedding this plan into the bigger plan, right? So this way, we are not just assuming that the function is super light; it is getting the right, weight within the overall plan. Super, super useful. Okay, how do we use all these features? It's extremely simple. The only thing we have to do is just enable the user database compatibility level to either 140 or 150 if we want to use the features in 2019, right? As soon as we change the compatibility level, we are using all these features that I have presented till now, right? We also have the possibility of enabling and disabling each of the features that we mentioned using different hints. For example, let's say that you have your user database in compatibility level 150, and for some reason you don't want to use the intelligent query processing feature that is targeted to inline Scala using functions. You can disable it with a simple hint, right? Or if you just like to not use it at all, you can just change your compatibility level to 130, for example, right? But it's as simple as just changing the compatibility level, right? And you have all these features right at your hand. Mm. Another feature that I love, actually, which is extremely useful, is lightweight query profiling, right? What can you do with lightweight query profiling? Let's say that you have a procedure, a report that is running within your instance, right? And how do you know at which point of the execution that process is, right? If it is at 10% of the execution, if it is at 50%, or if it is about to finish at 90%. You don't know it, right? Well, with lightweight query profiling, now Microsoft in SQL Server 2019, by default, every single process that is running within the SQL Server, you will have the estimated query progress, a number which is a percentage which goes from 0 to 100%. So you will see at which point of the execution you are at, right? And with that number, you can take better decisions, right? If it is starting but it took several minutes or hours, you can take one decision. If it is about to finish because it's at 90+%, well, maybe it works just to wait a few more minutes, right? But now we know this. Before we were blind, right? And this feature is, as I said, it is enabled by default in SQL Server 2019, but Microsoft made something really good with this. It ported back this feature to SQL Server 2017 and SQL Server 2016. It is not enabled by default. You have to enable it with a global trace flag 7412, right? But you have it available also in 2016 and 2017. It's quite lightweight, so it's not impacting on the overall performance. And again, it's extremely useful. Well, then we over the years, we have all these problems related to how we configure, how we dimension, how we create Tempdb, the number of files in terms of where we put the data files, the log files, number of files per course, etc., etc., etc. But even though if our workload is Tempdb intensive in the way that we have, let's say, one procedure that is constantly dropping and creating temporary tables, right? Within SQL Server, we only have one Tempdb, right? So we are generating latches because one procedure may be waiting for the other until the table gets created and drop, right? Then in SQL Server 2019, Microsoft has introduced this Tempdb metadata approach. If you remember from previous SQL Server versions, we have the possibility of having in-memory OLTP. That means creating user tables in memory, so the table resides in memory, so we don't have this problem of latchings. So processes waiting one for each other in order to access the table on the disk, because now there are no latches, everything is in memory, so there is no restriction in terms of the how we access this. Okay, Microsoft in 2019 put this concept for certain Tempdb objects, right? And for example, the metadata of the temporary tables now get created in memory, right? Not the data itself, not the rows that you put within the temp table, but the metadata, right, resides in memory. This way, you don't have to wait in this process of dropping and creating the Tempdb object, because it's in memory and you accomplish a great performance just enabling the feature. It is quite simple. This is a feature that it is disabled by default in SQL Server 2019. You have to enable it, and it is at instance level. So you enable it, you have to restart the instance, and the feature is present, right? If you want to disable it, you disable it and then restart your instance again. So it's at instance level. So let's see all this in action. So I have a virtual machine over there. Have a virtual machine here. So let's start with a live query statistics. So I have this query in my management studio, right? And I will enable it live query statistic within management studio here. And I will run, let's say, this guy. When I execute it, oh, I have to, it's not on, yeah. When I execute it, note what I have here at the top, estimated query progress. It was quite fast, so we didn't capture. So let's run it one more time. You will see that I have the query running, and here, and also down here, I have the estimated progress, right? So I see at which point of the execution I am at, right? I will run this one because we will see it a little bit better. So you see here, no, this is running. We see all the operators running, and at the top here, we also see the estimated query progress. With this value, with this information, we can take, again, smarter decisions and see what we do. Again, available by default in SQL Server 2019, Azure SQL, and if we want to use it in 2017 or 16, we only need to enable a global trace flag. Oh, okay, very good. So I'll cancel this. Then let's talk a little bit about Query Store. I have my Query Store script here. I am running on a SQL Server 2019. So what I did here is I did create a user database and I did disable Query Store. Then I'm creating a table here, right? I'm just creating a table and a store procedure. The store procedure is basically quite simple. It's doing a select from that table that I create and is using the parameter that I pass here in order to retrieve. And then I'm filling up the temporary table with certain data. I ran all this part already, right? So because that takes a few minutes. So what I will show you here is that this table has all this dummy data, right? So now what I'm doing here is I will enable Query Store, as simple as alter database state Query Store on. So I'm enable it. I will execute this procedure that we create with the parameter 0 20 times. So I just run my store procedure 20 times. If I go to Management Studio, I go to my database, then I go to Query Store, I go to the reports, and I will go to this one, which is regress query, for example, and I get my report. It's populating. Let me go again. Top resource consumption query. So here I have my query, right? My store procedure. I have at what time it was executed and the plan that is in cache. If I go here and see the information in grid, I see that it was executed 20 times, right? With a minimum duration of 3.5 milliseconds and a maximum duration of almost 15, etc., etc. Right? So I see all the runtime information. So now let's go back to my script here. Let me move it a little bit. What I will do right now is I will create an index on this table in one of the columns, and I will execute my store procedure against another, let's say, 25 times. Get the index. Yeah. So I'm executing this 25 times. When I go back to my query store dashboard here, right, I see that now for the same query, I have two plans, the original and the new one. You see that the shape has changed, right? And this is because now I have non-cluster index. If I go to the runtime statistic, you see that right now with the new plan, right, that was executed 25 times, the minimum and the maximum duration also, of course, the average duration is way, way lower than the initial. So we capture all this. So then I will come up again and I will create another non-cluster index and I will execute my store procedure, let's say 40 times. When Okay, so I go back here, and now we see that there is a third plan, right? So we have here all the plans stored over time, right? If we go here, we now see that the new plan is much better than the other one because the execution is faster. But let's say that for certain reason, right, I would like to force this procedure to use the initial plan, right? The one that was the worst of them. I can just simply go here, select, and then use force plan. It will tell us, are you sure that you want to force this plan? We will say yes. And now here, as you can see, we have this black check, right? So now it's saying that the plan is forced, right? So if I go back to my script and I execute the procedure another 40 times, right? I go here, I go again, and we see that now in bold, we have the plan ID 1, right? Which is the one that is forced, which is the worst of all of them. But since we force it, we are using this one right now, right? So again, this is a quite simple example to see that we are just tracking only one process here, but we have multiple processes running. We're gonna see all them in here, and we will be able to keep track all the plans and the changes over time. This is quite good. All right, so let's see now automatic query tuning in running. So, and for that, what I will do here is we have, let's do this demo. I have this performance monitor just tracking batch requests per second. I have no activity on my instance right now. So what I will do here is I will set up my demo. And what I'm gonna be doing here is just running, a store procedure multiple times, right? And now we see that my batch requests per second, right, is now an average of, let's clear, it's an average of 110, something like that. So what I'm gonna do right now is I will manually introduce a plan regression, right? So now my plan has suffered a regression because of certain situation. And now we see that my batch requests per second, right, went back to a low number, right? So now it's too bad. So what I need to do as a DBA is just go to Query Store, identify the problem, and manually fix the plan for that particular query ID to go back to a reasonable performance. What the problem is, again, if this happened at 2 a.m. in the morning, we have to be there. So what I'm gonna do right now is I'm killing this. I will clear. I will reinitialize my demo. And what I will do here, it's just this. I will tell the user database to set automatic tuning force last good plan equal on, right? Let's see what happened when we do this. So now automatic query tuning is enabled, right? So let's go back to my performance monitor. Let's go back here and execute the random workload. Again, we are back to 100 something batch requests per second. And now I will generate the regressions. see what happened. So when the regression happened, all right, let's do it one more time. The batch requests per second decrease again, but immediately, right away, right, it get back to the previous value. And this is because automatic query tuning at the top of query store, right, has forced the last known good plan for this specific query and for all the queries that may be running within the user database. So if this happened at 2, 3 a.m. in the morning, we don't have to be there to manually fix it. SQL Server with automatic query tuning will do it for us, right? Really impressive. So let's close this guy. And let's check. Let's close this guy. This one too. Okay, so let's check the memory grant feedback. Do I have it? Okay, this guy. So what I have here is one of the sample databases, one war importers DW. I will set the compatibility level to 150, and I will clean the procedure cache, right? And what I have here is a store procedure, which is doing a couple of joins, nothing too fancy. So when I create the store procedure, I will execute it the first time with this parameter 8. I will enable also to show me the actual execution plan. When I run it for the first time, right? Oh, sorry. Let me do it here again. I will run it the first time with parameter 8. When we see the output, we get nothing, and we check the execution plan when we have this warning sign. When we go and check this warning, we see at the bottom this warning saying that query memory grant detected, right? Excessive grant. So it was assigned certain amount of memory which it was not used. So okay, that's the case in where we got additional memory and we never use it. So the plan is now stored in cache, right? So I will run my store procedure one more time with a different parameter, 9. When I run it, see that this time it will return certain rows, certain amount of rows, 231,000, right? And it took 4 seconds. When we go to the plan, now we see that is plenty of this warning. The memory grant detected, the sort now is using the Tempdb to spill the data, and also for the hash match is also spilling to Tempdb. Why is that? Because the initial grant was not enough for this execution. Let's see what happens if we run this procedure one more time without doing any code change. This is important because all the things that we have seen till now, we don't have to go to the code and do any change, right? It's just working with this feature. So I will run it one more time, right? Instead of 4 seconds, it took 2 seconds. It returns the same amount of rows, of course. But see what happened. If we go to the execution plan, we don't see any issue related with warning, right? And this is because memory grant feedback was detected and adjusted the plan on the fly, right? So the following execution, right, it adjusts the grant to use exactly what it needs, right? Not more, not less, just what it needs, right? So it runs, it adjusts, and the following execution, it's just using the new one, right? And this is happening constantly. So if I go back to the original execution, that the one that returns nothing, if we go to the plan, again, we see excessive grant. But if I run it for the second time, that warning is gone, right? It's constantly adjusting on the fly, right? Really, really powerful. Very good. So we are getting close. Okay, so let me go here. Excellent. So with this, we have covered all the these features that are part of SQL Server and Azure SQL, which allow us to get good performance, but overall to have a stable performance, right? Historically, the problem that we have with SQL Server is that suddenly something that was running okay, now it's not, right? And without any code change or anything major, right? And we had to start, recompiling or doing DBA's magic in order to solve the problem or mitigate the situation. Now it's all part of these new features within SQL Server. If you would like to learn more about this, I leave you this QR code in where you can see all the features, not only the features related to performance, the one we just covered, but also the ones related to security or availability that are part of SQL Server 2019. Additionally, another link that is also focusing to the documentation for the Azure SQL fundamentals. If you would like to learn more about the whole Azure SQL family, product and services, how to use them, etc., and eventually go to take one of the certification exams, all the information is here. And with that, we just reached the end of the presentation. I'm not sure if there are any questions in the audience. Again, if you would like to follow up by my contacting me, you are welcome to do it.
Yeah, there are no questions as far as I can see. So I guess we can close the session. So thank you very much, Javier. It was a great session, and hope you to catch you soon somewhere, maybe in person in the next year
hopefully.
or so.
Hopefully.
At some conference. So hopefully, yes.
Hopefully. Thank you so much. Thank you for the invitation again, and talk to you later. Bye, everyone.
Okay. Cheers.
Bye.
Bye-bye.